Okay, I'm running a little behind on getting you this information, but hope everybody's doing well and hadn't got this virus that's going around. And make sure and take precaution, and we will make it through this, and hopefully won't get too far behind. The main thing is concentrate on your families and try to keep everybody well, and try to keep working if that's possible. But anyway, this is going to be the lesson and the video from the switchboards, switchgear, and panelboards on the March the 19th lesson. And like I say, do the answer the questions at the end of the book, and we will go over them. But maybe we have the okay to resume classes on the 26th, which is this coming Thursday. And I look forward to that. If something changes between now and then, I will get with you. But okay, here we go. I'm going to start the video and hope the quality turns out good.
408 switchboards, switchgear, and panelboards. The scope of 408.1 is switchboards and switchgear. By the way, switchboards and switchgear, unless you're a gear guy, you really can't tell the difference between the two. And forever, we had switchboards and panelboards. And somebody said, last code cycle, what about switchgear? And they're like, oh, well, we just assumed we knew what. So it didn't? So the National Code never covered switchgear until 2014 NAC.
What's a load center?
Okay, a load, you guys are going to have to help me here. A load center is a panelboard, isn't it?
A load center is a marketing term
Right.
for panelboards.
For panelboards.
Okay.
Yes.
But then what do they call the other ones?
Panelboards.
Okay. So you have a load center, you have a panelboard.
A load center is the low-end dwelling version of a panelboard. That's the easiest way to
And
say
a
it.
panelboard in the industry is the high end.
Commercial, and typically, not always, but typically has bolt-in breakers, whereas a load center typically has plug-on breakers.
Panel boards or panels
That was
like
free.
you'd use for smaller breakers.
Arrangement of bus bars.
MCCs, what I call
408.3.
the others.
We're just going to talk about the high leg. We previously had covered the high leg and
Very important.
110.15.
You'll
It
run
had to be
across
identified with
this
the orange
a lot
color.
of places in
Now we
Jackson.
are in panelboard, switchboards, and switchgear has to be on the B phase. Is the orange. We have to be aware that if you have a high leg system, you have to mark it.
Now, this
Phase
is only
B
on a
has
240
poles to ground.
three-phase system.
That would have been a nice thing when I was working in the field to realize, now I know why every third breaker was empty. We talked about that, I think, extensively back in 215.
Who are you kidding? You wouldn't have read the sticker.
Fine, all right, all right. Wouldn't have read the sticker. Afterwards, like, oh, it was a 208 high leg system. Field identification, 408.4. All circuits and circuit modifications must be legibly marked with an approved manner of detail to allow each circuit to be distinguished from all others. Spare positions that contain
They
unused
call it a
overcurrent devices must be
208 high leg
must be
system.
described
We
accordingly.
call it a 240
The part
three-phase.
about approved amount of detail, was that a 17 change or was that a 14 change?
I think that was a 14 change,
Okay.
and that's so the inspector decides what's enough detail instead of the person that's putting it on there.
Now, instead of sufficient detail.
Suitable.
Very
Instead
important.
of suitable detail,
Yeah.
it's approved amount of detail. Here's an example. All the switchboard, switchgear, and panelboards supplied by feeders in other than 1 and 2 family dwellings must be marked with a permanent, not handwritten label that withstands the environment, indicating where the power supply originates. So when you get to a panelboard, on the cabinet, we're going to have a marking in there letting us know, it doesn't have to be engraved panelboard, marking, but I mean, it could be something that's going to be permanent. 408.7, unused openings. And this is where you have, you need panel fillers. We covered this. It was something in 110, and then we discussed this in 314. Now we're talking about panel boards. Oh, and it was also talked in 312. That's right, because 312 is cabinets. And now they're talking about it in Unused openings for circuit breakers and switches must be closed by using identified enclosures for other approved means. Now, you got to be careful here. I know of one case where it was a square D I-line breaker panel board, and the guy had, I guess the way they were made, they were metal, and I think there was something like a thing in the back or something like that. Whatever it was, the cover was still on, but he was playing with the filler, and it fell in, it exploded. It was down in Brandon, Florida, which is like near Tampa area there. Guy caught on fire, and he survived.
The filler should have been insulated. I don't know what this guy was trying to
Just to
fill
be
up.
clear, that's not the new version. That's the very old version of the I-line panel. That's not really an issue with the new ones, but I'm sure there's still plenty of hazard there.
Eric?
Yeah, Mike, you didn't cover this. I just want to, but it brings up a good point. The article for 408.3E1 is AC phase arrangement, and it talks about alternating current phase arrangement on phase buses shall be ABC from front to back, top to bottom, or left to right.
Yeah.
The only reason I bring this up is that I've had inspectors read this thinking that, for example, the conductors terminating on a breaker should be ABC left to right.
I'm going to try to find
Pretty tricky here. I would pay
It's
attention.
408.3E1.
Oh, E.
Says alternating current phase arrangement on three-phase buses shall
This
be
is
ABC
maybe if you got to
from
swap
front to back,
the
top to
phases
bottom,
on
or
a
left to right.
three-phase motor.
Okay, be
Get out
careful.
of sequence.
This is bus arrangement in a panel. This is a great example of knowing where you are in the code. We're in Article 408, which is panels, switchboard, switchgear, and panel boards, and this is talking about bus arrangement. I've had inspectors cite this code saying that, well, look at the conductors terminating to the breaker. They're not ABC left to right. And my response is, okay, but this code is about the bus arrangement, not the conductors.
I'm missing something. How would...
In a disconnect, in a breaker type disconnect, you're not necessarily, so this relates only to bus, not to where your wires are landing in a disconnect or a breaker.
So I understand the code. I'm trying to understand the problem of the application.
Out in the field.
So
I'm trying to understand the application in the field.
So for example, on some square D I-line,
right?
You have the bus that the breakers stab into is A, front, middle, back. Well, depending on which breaker you're using and which side of the panel it's on, if you're looking at the conductors the way they're terminated, it's either ABC left to right or ABC right to left.
Oh, I see what you're saying.
And inspectors have turned those installations down, citing this code, but this code doesn't apply because it's only bus work.
Brian?
Well, also, if you need to change phase rotation in a motor disconnect,
Exactly.
that
That's
inspectors
what I was
are
talking
like, yeah,
about.
you can't do that. You've got to do that at the panel because it's got to be ABC. And I'm like, well, wait a second. That's has nothing to do with this. That's the panel. That's just so you know how the buses are arranged in the panel.
Oh, I see. You're trying to tell me that an inspector wants the black, red, blue, and he wants to make sure that that's an A phase, a B phase, and a C phase.
In the disconnect, he wants it black, red, blue.
Right.
Right. But the thing is, I needed the motor to run backwards.
Right.
I need it to run backwards for the equipment.
So you just changed the two phases so it's black, blue, red.
Right. Well,
Which is
I'm
fine.
not
It's
changing
not
the
that
wire
hard.
color because it really
Change it in
is
the motor.
phase A, B, and C. That is
Keep
the
the
correct
phases
colors, but I need to switch where the two phases are located in the disconnect. And of course, that causes a problem.
Ah,
So-
that's whether, okay.
So the inspectors are using this code section, which is specifically about bus work, and the inspectors are applying it to conductor arrangement, and it doesn't apply.
Okay. Let's move on. 408.36, protection of panel boards. Here's a panel board, which is the guts. Here's your cabinet. We have to protect this bus. We can either have a breaker here, which can be used to protect the feeder conductors, which protects the bus, or you can have a main breaker in the bus itself, which can protect the bus. There is an exception that you can have service conductors terminate to an equipment, and the panel board does not have to have individual overcurrent protection because you can have multiple circuit breakers as per 23071, which allowed us to have 6 disconnects. So that panel board for service equipment we have 1, 2, 3. It looks like this panel could only have 4, which is fine.
You see that a lot of times outside.
Panel boards on the secondary side of a transformer, as shown here. The overcurrent protection can be either at the panel board, or it would be, let's say, a feeder conductor providing the protection.
Most of the time,
All
you see a
secondary
disconnect
conductors have
feeding the
to terminate in
transformer
every
and then a
single case
main in the
to an
panel.
overcurrent device. And these
Right
kind of,
here,
not
this is the
small
most
transformers.
common. I like this
Two-wire
way, it
transfers do
keeps
not
this
require
out.
secondary overcurrent protection. Backfeeding a device. Here's the service conductors coming in, and we're going to backfeed that. So we're going to put a main breaker here. And when you backfeed that, we need to have a fastener that will hold that breaker in place, because what you don't want is backfeed a breaker, have that breaker pop out, and the bus is going to be energized. Brian?
Yeah, and that's actually, if you go back 2 slides, while we're talking about this, I want to bring something else up. This application right here, some of these panels, especially the smaller
He's talking about
ones,
if the
are only
breaker
suitable
pops
for use
out,
as
the back
service
of your
equipment
breaker
if
will
they
be
have
hot.
a
That's a
main
pretty
unit.
dangerous situation.
You
but it's
can't
been
come into
done
the
a
main
bunch
lines, not
times.
all of them, but Square D, for instance, does have a couple of their smaller panels that you cannot main lug them. They have to come into a breaker.
Well, this breaker right here would be marked suitable for use as service equipment.
It says that, and then it says if a main breaker is installed.
Oh.
Yes. So it's suitable for use as service equipment if a main breaker is installed.
So you would say if this was marked that case, then we could not do this.
And it's actually right in the cover, says right on the inner door of the cover there.
And it shows
says,
you the wiring configuration also.
Yes, it does. So
Okay.
just wanted to throw that point out there. Don and I were talking about that at some point, and I can't remember, but he
All right,
wanted.
so what you're saying, let's just don't make this general statement that you can always use a panel as service equipment and
Right.
put 6 breakers in there because we have to read the instructions.
Right.
Okay. I actually did not know that. 408.40, equipment grounding conductors. Pretty straightforward. The panel board, actually it's a cabinet, right? It's not the panel board. Let's see, where a panel board cabinet contains equipment grounding conductors, a terminal bar for the equipment grounding conductors must be bonded to the metal cabinet or be connected to the feeder equipment grounding conductor. Well, I was thinking that might be on 312, but that's okay here. I have a problem. You have to use a grounding bar kit that is specifically listed for that specific product, not a big 4/0 lug with fender washers and drywall screws. Not going to get into the details, but if you had an isolate ground circuit, you would be able to have that equipment grounding conductor travel through panel boards and also outlet boxes to get it all the way back to the source. We're not going to get into that exception. That's really not something that's really done anymore.
Can I ask
Hadn't
a
seen a
question
lot
about
of
the
that.
IGs?
Yes.
I had an installation one time that I called. They did an IG at a bank, and they mounted the ground bar to a piece of wood inside the panel.
Well, when you run isolate ground circuits,
Is that?
that equipment
Okay.
grounding bar should not be connected to the enclosure.
I understand that,
But
but
that equipment grounding bar, how long ago was that?
that was early 2000s.
Bingo. When we started going with isolate ground circuits, and then you were able to run through where you can take isolate ground bars, manufacturers were not, they don't move that, they can't move as fast as the industry is going to move it. So there was no way to mount that in that panel board at that time because they didn't make an isolate ground bar for that specific panel with the mechanisms to mount that in that panel board. Today, you can buy an isolate ground bar that has the isolators, the insulators, to make sure you do that. So that's the only reason why they used wood at that time, because there was no other way to do it. Because you didn't want to make a connection to the enclosure. Brian?
I just want to go back to a comment you made and ask a question. You said if you had a ground bar and you were putting it in a panel, it had to be listed for the panel that it was installed in and the cabinet that it's installed in. So if I had, let's just say on my truck, hypothetically, if I had, I don't know, a Siemens ground bar and I was working on a Cutler hammer panel, I couldn't put my Siemens ground bar in my Cutler hammer panel? Is that what you're saying?
I'm probably saying that, but what I meant to say was this, but I'm probably saying that. What I meant to say is this: you need to have a listed ground bar.
Okay.
It's listed
Not
for
for
grounding
that
and bonding.
specific
But
panel.
I'm going to go that in a second. It needs to be a
Okay.
listed ground bar. It can't use a 4-aught log with a fender wash and a drywall, drywall screw, and it's just kind of like making it. It's going to have to be a listed ground bar.
Okay.
I'm assuming that Square D, Cutler, Hammer, whatever it is, they have a specific marking in their instructions to say that when you use a ground bar, they give you a specific product number. And they tell you what ground bar is to be used with this particular cabinet. I'm pretty comfortable to say, technically, that if you use somebody else's ground bar, then you're not compliant with 110.3b. You're not installing the equipment or using the equipment in accordance with this listing and standard. But that's the same thing as you go in there and you put a GE breaker and you put it into a Siemens panel or a Murray breaker, and then you start using products that will fit. Then we get into that, is it really technically correct or not? I'm not worried about that. I'm worried
I
about
think they're
people
splitting
terminating
hairs
equipment
on
grounding
this.
conductors,
You don't ever
not
run
in grounding
across
and
that.
bonding fittings. But I still would be worried about somebody taking a fitting that's not listed for that panel board because maybe the holes are not lined up the same way. Maybe it has more than one hole.
You can
know what I
drill
mean?
your
So I
own
would
holes,
worry.
and
Here's what I'm trying
nobody'd
to
ever
say.
know the difference.
When you buy a piece of equipment and you're going to have equipment grounding conductors, you should order the equipment grounding bar with that equipment at that specific time. If you're doing a service call and you're going in there and now you're trying to put a ground bar inside there, that's a whole different ball game because you're going to do what you need to do. It would bother me to see you put in a Square D panel board and use somebody's ground bar that wasn't made for that thing when you first did the job. That would bother me. And if I was an inspector, I would want you to use the ground bar that was for that panel board.
Yeah, we ran into it a lot in the field where it was bonded in two places and it shouldn't have been. So, of course, when you pull the bond screw out of the one panel, you've got to separate the neutrals and grounds.
Right.
So you just use whatever you had on your truck,
Is that a new installation?
Service,
or
service,
That's
yeah,
what I'm saying. When
service,
you
yeah.
get into understand something, we're only dealing with a brand new installation,
Not a repair.
Yeah. Now, when
see.
you go into
That's
a
right.
repair application, something that's 50 years old, 20
Sure.
years old,
Okay.
products that were installed at one time, you had wood now on an insulating ground bar So we just got to be careful that if it's in service, we want to make it safe, and then you got to figure out how to make that safe. Okay. Equipment grounding conductors. Again, I believe you have to use the product that's listed with that specific product in service work. I'm
See
not gonna
this
talk
done
about
a
that.
lot right here.
And equipment grounding conductors must not terminate on the same terminal bar with the neutral conductor, except as permitted in 250.142 for services and separately dry systems. So the neutrals would be on the neutral bar, equipment grounding conductor on the equipment bar. So if this is not service equipment, which the main bonding jumper or strap is not installed, then that would be a violation. Neutral conductor terminations. The neutral bar is to be used for the neutral conductor, and only one neutral conductor is permitted to be installed under a given terminal.
You see this violation.
Here's
a
an
lot.
example where you have instructions, and these instructions tell you the torquing requirements. Well, you have to make sure that you torque according to 110.14 for torquing requirements, but I want to show the violation here that you can only have one neutral conductor under a neutral terminal. However, the instructions on this panel board indicates that you have two 14s or 12s, and there's your torquing requirements. So two equipment grounding conductors are okay on a terminal because it's identified with the instructions, but only one neutral is ever permitted because 408.41 prohibits you having more than one neutral on the terminal. Brian?
Yeah, two other comments, and I think this was something Eric brought up. I've seen a lot with the equipment grounding conductor on the neutral bar. You still have both bars, but they mix them up where they'll put a equipment grounding conductor on the neutral bar and then, or vice versa.
On service.
Right. The other on the
no,
service.
Let's take one at a time.
Okay.
You're at service equipment. You're putting neutrals. Let's go up here.
Service equipment where it's bonded.
If this was bonded,
It's not a
this would
problem.
be okay.
Yeah.
Okay.
That's right.
What was the comment you were saying? I'm afraid I might have missed it.
They're putting a neutral and an equipment grounding conductor under the same terminal on
Well-
the neutral bar.
Well, we can only have one neutral, one wire.
Right. Just common violation. is what I
Okay,
was
yeah. You're
It's
saying,
common.
hey, listen,
Yeah.
at service equipment, they got neutrals and
Do
grounds.
see that
Yes.
done
They're
a
all
lot.
tied together. They're putting them all together.
So
And then-
they're confusing the fact that you can put 1 and 1 while they're putting 2, a
I
neutral and a
understand.
ground.
That's a violation. We don't have a picture of that. Well,
Yep.
we do have it right here.
And then the other comment was
Oh, no,
that,
we don't have a picture of that.
Siemens actually, I believe it, I don't know if it's anybody else, but for sure Siemens, they have ground bars that'll take up to 3 equipment grounding conductors under a single terminal now.
And it'd be under the instructions.
Right,
Yeah.
That allows them to make smaller equipment grounding bars.
right.
Save a little money there.
Yeah.
Hey, pennies are pennies. Heinz?
May I get a little pedantic?
Hold on.
Go
hold
for
on.
it.
Whoa,
The
whoa,
measure of
whoa. What do you say? What's that mean?
Pedantic.
What's that mean?
So he's like a pendulum, kind of goes.
Well, no, it's
It's boring. It's
boring and so
yeah,
much attention
intellectually
to
boring.
detail. The measure of torque is not inch-pounds.
Hold on.
It's pounds
Pound
inches.
I was wondering about that.
It's LBF hyphen inches.
So you're telling me now on the last day that all the graphics that we identify our torquing is wrong?
I don't know that.
It's a common
It really-
in industry a lot of times.
It's pound inches.
Yes, sir.
Right, and it's like you're supposed to say pound feet, but
Yeah.
a lot of people just say
Pound
foot
force.
pounds.
No, it's pound force. LBF hyphen inches. If you're using inches and pounds, it's force units hyphen length units. It's force through a
Pound
distance.
inches.
Yes, sir.
Right.
Pound inches.
Yes, sir.
5 pounds in an inch,
Okay.
5 pounds in a foot.
This will be corrected. Thank you very, very much. And that was called what? That was we were being
Pedantic.
Pedantic.
pedantic?
Yeah, it's a guy who gets totally focused on insignificant and irrelevant details, you know.
I think that's all of us. All right. Now, here's the problem by having more than either a neutral and equipment grounding conductor or 2 neutrals is that if for some reason, okay, on multi-wire branch circuit, we
This
went
makes
this at least
sense
twice.
right
We
here.
covered
Pay
this
attention here.
in multi-wire branch circuits in Article 100. We covered this in 210.4 on multi-wire branch circuits. And what happens if you have a multi-wire branch circuit, this is fine. Neutral currents are fine. But then if you open that neutral, then it becomes a series circuit. And then we find out that one appliance will burn out and the other one might not. I have to tell you a story. I get a multi-wire branch circuit, and I want to prove this. What I want to do is I want to show that the ground rod, whatever it is, I went to remember that one remote building disconnect I had my grandson
I
inside
think he's
there?
explained this before.
Okay, so I went out there and I opened up the cover and I disconnect the neutral, turn off the power. I disconnect the neutral going to my remote building. I then I disconnect the neutral there, but I have a ground rod. And I wanted to find out, well, what would be the voltage, and what's the voltage, the touch voltage on the metal building when I have a hot going to a load, going to the earth, returning. You with me, guys? So the earth is going to have a certain amount of voltage drop. My load's going to have a certain amount of voltage drop. You follow me? And then I can find out what the touch voltage is because all the metal parts are connected, but there's no neutral. How many guys understand what I'm trying to say? But what I don't want to do is have a multi-wire branch circuit. Because I know if I do a multi-wire branch circuit and I disconnect the neutral, then I'm going to have all these voltages. I'm going to burn things up. I'm pretty smart. I'm writing for Power Quality Assurance Magazine. It's very, very cold, probably in the 50s. Hey, that's cold. And I usually run around in boxers or something like that when I'm working. So I probably had boxers. I get my toolbox. I'm running out there. I open up the cover. I disconnect the neutral. I take the neutral, connect it to the enclosure because that's at a remote building, right? So I can't do that. I disconnect the equipment grounding conductor. I turn on one circuit breaker. I have my voltmeter, and it goes to, let's say, 60 volts on metal parts, and then it goes to 40. It doesn't matter. I'm cold. I put the covers back on, get it all done. My brain is still thinking, why did it go? You know,
Be
I think it
careful
was an
trying
analog
this at
voltmeter
home.
or
I
something
don't
like that.
want to
Whatever.
burn
Like,
up a bunch of
that's
stuff
funny.
myself.
It doesn't matter. I close it all up. I go back in my workshop. The sun is going down on a fall day, kind of cool day. Just at the time, and it goes, hallelujah. You see that beam of light coming down. I'm thinking, that's funny because I didn't notice that beam of light coming in my workshop when I got my tools out. And then I realized, okay, the reason I'm seeing the beam of light is because there's what in the room? Smoke.
Whoops.
And I'm thinking,
Whoops.
how could I have smoke? And where does smoke? Did I cause a fire? What happened here? I look up and I had like 5 fluorescent electronic ballast fixtures, okay, maybe electromagnetic at that time, and 2 of them were smoking. And I'm sitting there, I'm thinking, okay, do you know how long it takes to replace a ballast in your workshop? I mean, it takes years.
Forever.
I mean, I don't know if they even happen, if they can even be done. But I mean, it's going to take a long time. I look at that, I'm like, oh my gosh, the size of that. I don't know if I'm ever going to get to it. So anyways, I'm looking at it, I'm like, I'm cold. I just want to get back. I'm like, but what happened? Here's what happened. When I took the one circuit over and I went to my loads and then I went to the earth had that voltage drop distribution there. I had a certain amount of voltage because I had all those fluorescent fixtures as part of my loads. But when I had, so what were they not operating at? They were not operating at 120 because I was distributed according to the earth. I mean, through the earth, that voltage distribution. And as I started popping them off, right, that's where my voltage when I was outside kept changing as I would start burning up the electronic ballast. That's the first time that I actually realized that when you open a neutral, look at this graphic here. Yes, you can wipe out equipment because of over voltage. But if this was inductive loads right here, you could wipe out the inductive loads because of under voltage. So the hazard here is that that you never have more than one neutral under a neutral terminal, and that's the way neutrals get terminated. Because if you had more than one neutral, it's possible that you're fooling around with one neutral, and just while you loosen up that screw, and then all of a sudden you notice a little spark, and when you put it back on again and there's no little spark, that's because you wiped out your equipment. Okay, I'm done with panel boards, switchboards.
Okay, I am going to try to send this to you through a YouTube video link, and hopefully I can send it to your text message and you can link on it and get it on your phone. We'll see about that, but if I can't, I may try to send it to your TCAT email address. So I hope everyone can get to that TCAT email address, and we will continue on the 26th with luminaries, low voltage, and lighting system, and try to get caught up and get up to speed. And like I say, be safe, work safe, keep your family safe from this this virus. I don't know, this is a different time than I've ever seen, but we just have to do what we can to, we will make it through it, and hopefully the other side will be a better economy and people will have a little better understanding and appreciative of just being back to a normal state in the country. So, all right, that's all I have to say, and we'll see how this works.